Hello everybody, I'm Rofiner, and today we are going to see how to check noise profile. So the main thing that we are going to take a look at, the main thing to check is the flight noise level curves from the noise result PDFs. I made a few sketches here to show you what would be a perfect profile and what to be a profile that we want to reject. So that's the perfect profile. Basically, we get a curve which is really close to the standard deviation of 1, whatever the brightness value. In practice, it is very, very frequent that we get some bump here in the shadows, and we can get as well a little peak like that in the very high brightness. That's nothing to worry about. The main important thing is that for a very wide range of brightness here, we are really close to a standard deviation of 1. When you see a curve like this, actually, you may think that the profile is really bad because we are quite far from 1. But actually, this slope, the slope of the curve, it's not controlled by the profile. So actually, when we get such kind of things, usually it's for very high ISO values, it's quite rare, and it has to be taken with the context of the other ISO values. We can, if we see that the curves, as we get to higher and higher ISO, gets a slope like this, which is becoming negative, then it's just the behavior of the noise for this camera. We cannot do anything special with a profile to make this right, because, well, this is an example which is a bit less extreme, but because what we don't want is curves like this. Here we can see that basically, the trend is not at all near 1. Here it's near 1.6, 1.7, something like that. We can see that the curve actually is not centered around the right standard deviation. And this, we don't want this, because it will impact how much the result will get smoothed in terms of processing. So that's typically what we don't want. But if we get stuff like that, for example, this can be expected for very high ISO values, and this would be perfectly acceptable. So let me move on to an actual real noise profile. I took this one because it's very good. We can see that right here in the shadows we have a little bump. It's okay. We can see the curve here is very good, very, very close to 1. On the red and blue, this kind of step, it's very frequent, so nothing to worry about that as well. And the small peaks at the end of the curves, it's okay as well. So when I go through the file, I check every flat noise level. What we can see here is that we get some noise that we didn't have before. Actually, that can be explained. If we take a look at the histogram, we can see that the histogram for the green channel, basically we have much less values of high brightness than values of brightness until 0.7. And if we compare this histogram with the histogram we had the value before, we can see here that we had an histogram where we had a lot of values, whatever the brightness value, which explains that here we have a curve, a green curve, which is very, very very clear with very little noise, whereas here there is some erratic behavior which is just due to that. Nothing to worry about. This is a very good profile. I'll go on with high ISO value. Actually, I check, of course, all the curves when I check a profile, but I want to show you what happens on high ISO value. You can see that we get this kind of trend in the shadows. It's typical in high ISO value. And you can even have a kind of slope on the curve, all along the curve. And that is quite expected. You can see actually that it's getting a bit more pronounced compared to some lower ISO values. Like here, it was to 1.8 maximum, and right now we are above 2. But it's the same trend, basically. So when you see that increasing ISO, you have the same kind of curves with that kind of trend. It's expected, basically, that the little bump here gets a bit higher, and sometimes the slope gets a bit negative. That's normal, that's expected. Okay, and then once I've checked all these curves, what I take a look at is the JSON file. So for this file, I'm mainly interested in this column. So this corresponds to the green channel and to the A parameter. The A parameter is important. It's the most important one because changing A is equivalent to changing the strength in the denoise profile module. What I mainly take a look at is if I take a look at an ISO value, if I double the ISO value, the A value usually it's multiplied by 2 also. So for 125, I've got an A value of about 3 to the 10 minus 6. If I multiply by 2 the ISO value to get 250, I get something which is almost 6. So almost 2 times this value. So this is a trend which is very frequent. It allows to check consistency of the noise profile. So usually when we multiply by 2 the ISO value, you multiply by 2 the A value as well. But there are some caveats for the extended ISO mostly. So you can see that for 64, 80 and 100 here, which is the range of low values for extended ISO, we are actually getting values which are very similar to 125 to 200. So for ISO 64, we get approximately the same value as ISO 125. For ISO 80, it's approximately the same value as ISO 160. And for ISO 100, it's approximately the same value as ISO 200. That's expected behavior. Same kind of things here for extended ISO in the high ISO. So basically, the values here are almost equal. So it's not exactly the same kind of behavior that for the low values, but the behavior is no more multiplying by 2 ISO means multiplying by 2 the A value. Why do we check mostly the green? Because darktable currently it only uses the green value of a profile for in the denoise profile module, so that's the most important one. All right. Another thing is that on dual gain camera, you may have some A value which becomes lower at some point. It's not the case here, but we could, for example, have an A value of 1 to the power of 10 minus 5 here at ISO 800 due to dual gain, and then we get back to the expected behavior when we multiply by 2 the ISO value, we usually multiply by 2 the A value. Alright, one last thing we can do is check the little thumb picture to check that they are very blurry. If they are not blurry enough, it's not good. Beware also to be sure that they are all the extended ISO values. That's one of the most common mistakes I see. In about 10% of the noise profiles, the user forgot about some extended ISO values. So double check these. So now you know everything to check a noise profile. Check the curves, especially that it's centered around standard deviation 1. Check the histogram if needed. If you see some strange behavior of the curve, it's possible that it's just some brightness part where we don't have a lot of values. Check the behavior of the number in the JSON presets file. Check that we have all the ISO value and check that the pictures are blurry.